Guys, welcome to our first lesson in Algebra 1. Today we're going to be talking about numerical expressions, and I will try to be clicking through this as I go through the material, and you may also follow along in your workbooks. But before you start in your workbook, I would like for you to pause this video and try this warm-up on a separate sheet of paper. So I'm hoping you paused. -1 plus -17. Since these are both negative numbers, we add them and keep the negative sign. So it would be -18. Okay, the next one, 21, take away 13. And I sometimes hear students say, PIMDA says we add before we subtract. That is not the case. We add or subtract whichever one comes first as we're reading the problem left to right. The same thing with multiplication and division. We multiply or divide depending on which one comes first. So I'm going to go ahead and subtract 21, take away 13 is 8. 8 plus a -4, it's kind of like saying 8 minus 4, is a +4. Okay, when I see on number 3 this double negative here in the middle, I'm going to change that to a positive. So -8 plus 7 is -1. -1 plus 2, because it's a double negative again, minus a negative becomes a positive, and I get a +1. On number 4, -5 plus 4 is a -1. -1 plus 3 is +2. And on number 5, it says, one winter day, the difference between the warmest and coldest temperature in the United States was 74 degrees Fahrenheit. If the warmest temperature of 61 degrees Fahrenheit occurred in Arizona, what was the coldest temperature which occurred in Alaska? Okay, so the difference between the two, difference means if we subtract the two, we get 74 degrees. So it says the warmest temperature was 61 degrees. So we know that 61 subtract some number gives me 74 degrees. So if it's 61 and I subtract a number to get 74, then I know that it must be a negative number because a double negative then is a positive. So 61 plus 13 is 74, or 61 minus -13 is 74. All right, so let's look at the vocabulary in this lesson. Today's vocabulary is numerical expression, exponent, base, and evaluate. A numerical expression, we'll get more involved in these in the lesson, but if you just want to quickly jot these down, you can pause the video and do that, or you can, as you're working through your workbook, just highlight these definitions. But we're going to talk about each one of these, so rather than me read them, I'm just going to jump into the lesson and explain them as we go. A numerical expression involves numbers only. We are not going to have letters. It's not going to contain the alphabet. It only has numbers and mathematical symbols. So Lucy's baking cookies to sell at her bakery. She can fit 12 cookies on a regular cookie sheet and 24 cookies on a full-size sheet pan. She bakes 6 batches of cookies on a regular cookie sheet and 8 batches of cookies on a full-size sheet pan. You can write the numerical expression to represent the total number of cookies that Lucy baked. So we've got these cookies over here baking. She can fit 12 on a regular sheet and 24 on a full size. So if she bakes 6 batches on a regular cookie sheet, I have to write this down as I go. I don't have paper here. I don't know why I didn't think. Here we go. So she can fit 12 on a regular, and she does 6 batches on a regular. So I know that's the same as 6 groups of 12, right? Then it says that she does 8 batches on a full-size sheet pan. Okay, on a full size, she can hold 24. So she's got 8 batches of 24. And we know that if we were to add those two totals together, then that would give us how many cookies she baked. So this is probably going to be backwards to you. Here we go. Yes, it is backwards, but that's okay. You can imagine with me that I did 6 times 12 plus 8 times 24 to get the amount of cookies that she made. Okay, so we're going to look at writing numerical expressions. What is a numerical expression? We already talked about this, but once again, it's a phrase that contains only numbers and mathematical operations. So for example, 6 plus 2 divided by 1. This is a numerical expression. Sometimes expressions contain multiplication. Multiplication can be represented with this dot. It can be represented with parentheses around either of the numbers or around both of the numbers. Notice that we did not put the x. You guys are used to seeing like 2x3, 2 times 3. We don't really write it that way in Algebra 1 because x is an unknown in Algebra 1. It's something that we're solving for. So when I'm talking about multiplication, I very rarely will write an x in there to show timesing. So let's try a problem here. It says translate 1 plus 8 divided by 3 into a numerical expression. We know that plus is the add sign. Divided by is just our division sign, and it's divided by 3. Now, if we think about it, we've got to think back to algebra or 8th grade math. Think about your order of operations. Please excuse my dear Aunt Sally, parentheses, exponents, multiply or divide, whichever comes first, and then add or subtract, whichever comes first. So what would I do first if I was solving this problem? Of course, we would do the division first, then we would add that 1. And then just to think about it, I've already done this and I forgot to reset it, but addition is the same thing as plus. Subtraction is the same thing as minus. Of course, we know multiplication and times are the same, and division is the same as divided by. So let me see if I can reset my activities now for future ones. Okay, if you notice, I'm skipping over the extra examples, but if you log on to your course workbook and you click on the little tab, there's a little arrow. You click on the arrow and it'll drop down and say Module 1, Module 2, Module 3. Click on the arrow beside Module 1, and then you click on the actual lesson 1 under module 1, and it will take you through all of this, and you can practice these problems on your own and do the extra examples to make sure that you are understanding the concept that's being taught here. I highly encourage you to do that. So it says translate the sum of 5 and 9 divided by 2 into a numerical expression. So this entire sum, remember sum is the answer to an addition problem, this entire sum is being divided by 2. So it's important that we put parentheses around that sum to show that we add it first and then divide that whole process, that whole answer by 2. Another way of writing this is using the division bar. So 5 plus 9 on top, that shows that that is a group. It acts as a grouping symbol. It groups everything on the top of that problem together and then divides it by 2. Okay, so let's try it again. A person's handicap in bowling is usually found by subtracting the person's average from 200, multiplying by 2, and dividing by 3. Marley's bowling average is 170. Write a numerical expression for Marley's handicap in bowling. And I really thought that I just hit reset. Did I not do that? Reset. So that we can do this together. So it says that the first step is to finding the handicap is to subtract the average from 200. Well, it tells us in the problem Marley's bowling average is 170. So I'm going to come down here and I'm going to type in that 170 and I check it and it's going to take me then to the next part. Once we find that value, then we multiply it by 2. So it's important to put that in parentheses. And you guys do this a lot. You put that parenthesis, or you you don't do this a lot. You don't want to write out the steps like this is doing. What you want to do is just do it in your head, and you know to go ahead and subtract that first, then multiply by 2. But I want you to start writing it down. Get in a habit of writing down the process that you're working. What did we do first? Well, we subtracted the 170 from 200. What do we then have to do? We have to multiply that whole answer, that difference, by 2. When I do that, then I divide that by 3. It says up here, divide by 3 to find her handicap in bowling. And so that is the process. Okay, so I would like for you to take a minute, pause the video, and do this lesson check. It is also found in your workbook. So I'm not going to go through this, but I want you to do the lesson check that is in your workbook following that. And now we're going to look at evaluating a numerical expression. Okay, anytime I have something raised to a power, right, there's a little exponent there. The expression of the form x n is read x to the nth power. The word power can also refer to the exponent of the expression, the value, or the exponent of the expression. So we've got two parts of a power. We've got our base, and we've got the little bitty number, which is the exponent. This whole thing together is called a power. The bottom number is called the base, and the little itty bitty number is called my exponent. So when n is a positive integer, the exponent indicates the number of times a number is multiplied by itself. In a power, the base is the number that's being multiplied by itself. So if I have 5 to the third power, imagine with me here, 5 to the third power. I don't think I can write on my screen. I wish that I could. But if I could write 5 to the third power, that's saying that I have that base 5 multiplied by itself 3 times. So 5 to the third is not 5 times 3. It's saying I've got 5 times 5 times 5. It's going to be a lot bigger number. 5 times 5 is 25. 25 times 5 again is 125. Notice, not the same as 5 times 3. So don't make that mistake. And when I'm evaluating an expression, we're finding its value, it's important to know that we find parentheses first, then we take care of our exponents. So, concept of order of operations. First, we evaluate the expression inside of the grouping symbols. That's inside of the parentheses. Then we take care of all powers. We do those little exponents. Next, we multiply and or divide. We do whichever one comes first in the problem as we're reading it from left to right. Next, we add or subtract from left to right, and then our problem is complete. So this is order of operations. So let's look at example 4 here. It's taken a minute to pop up.